and running. Ah, there we go. Now our microphone's working. Perfect. Hello, biologists. Hello, hello, hello. One small technical issue before we started. How's everybody doing? I can see we've got Daniel in. Post a little hello in the chat so I can see who else we've got here as well. How's everybody doing? Are you having a good half term too? How are you all? How are you doing, Daniel? How is everybody doing? Who else have we got in then today? What are we saying then, team? What are we saying? I'm going to put a little poll in the chat as well about Paper 2 Cram. Who has signed up for the Paper 2 Cram course? So tired from the past 2 weeks. It's been long, hasn't it? It's been long, Daniel. It's been a long old slog. That's the problem with GCSE season. That's the problem with those GCSE exams. It really does take it all out. It really is a bit of a drain. So today we are looking at the final required practical for paper 2. We're looking at investigating ecosystems. So it's all about quadrats and transects. So we're talking quadrats and transects today. Paper 1 was really nice, and I'm praying for a good paper 2. Yes, I hope paper 2 is good for you as well, Daniel. I hope it goes well. I'm glad that paper 1 went well. Okay. All right. Let's take a little look. So, first thing we want to think about is describe how to measure the population of daisy flowers in a field. When we're estimating population size, this is where we're talking about using our quadrats. So using the quadrats, we are going to estimate the population size. Remember that quadrat is that square metal frame. Now, the first thing we need to do is we need to know what area we're going to be sampling, what area of the field we're going to be investigating. So the first thing I'm going to do is I'm going to mark out the area. So I'm going to mark out the area to be sampled. Once I've marked out the area to be sampled, I can then determine the total area of that field. I'm then also going to apply some coordinates, and I'm going to assign random coordinates, or I'm going to select random coordinates. And to do that, I'm going to use a random number generator. So use a random number generator. This absolutely could come as a kind of a 4 marker or a 6 marker, Daniel. Yeah. So I'm going to use a random number generator to assign the positions to place the quadrat. Now, it's really important that we use this randomness here. Now, the reason for the randomness is it helps to avoid bias. It means that we can avoid the bias. And because if we were investigating, if we want to try to measure the population of daisy flowers, I don't want to spend all afternoon in the field just counting nothing in my quadrat. So I might kind of be biased, and I might go and place the quadrat in areas where there are more flowers, perhaps. Or maybe I'm feeling really lazy and I can't be bothered to count anything at all. So I might place it in areas that don't have many daisies. That would be biased. And by using a random number generator, we are going to avoid that bias. So what we're then going to do is we're going to place our quadrat, and we're going to count the number of daisies within the quadrat. So we're going to count the number of flowers in the quadrat. And once we've started counting the number of flowers in that quadrat, well, there's a few ways we could do that. We could just count the number of individuals, but sometimes we might have plants where it's really hard to distinguish between the individual plants. So we could also perhaps use something called percentage cover. How much of the quadrat is covered by that specific plant species? What percentage of the area is covered by that plant species? Now, once we place the quadrat, what do we think we're going to do? Are we going to place just one quadrat? Are we just going to do 2 quadrats in my field? How am I going to make this experiment more reliable as well? Once I've placed the quadrat, I'm going to place 10. Exactly, Daniel. I'm going to increase the number of the quadrats that I've placed. So I'm going to repeat. And we could say around 10 times. And then whenever in an experiment we talk about repetition, we're going to talk about repeat and calculate a mean. Repeat 10 times and calculate a mean. And this would be mean per quadrat. Once we've got the mean number per quadrat, I then need to determine the mean number for the area, so the mean per meter squared. So then calculate the mean per meter squared. And to do that, all I'm going to do is I'm just going to do the mean divided by the area of the quadrat. Now watch out, because the quadrat isn't always 1 meter squared. Sometimes the examiners might be tricky and they might give you a quadrat that's like 0.5 by 0.5, in which case it would be 0.25 meters squared. And then once we've calculated the mean per meter squared, then I can calculate the total population size. So then I'm going to calculate the population, and I'm going to do that by multiplying the mean per meter squared multiplied by the total area. And this gives us our population size. Now, maybe I want to investigate how some abiotic factor affects the number of daisies, how it affects the growth of the daisies. So what I might want to then do is I could then compare the population estimate. So compare the population estimate to a different area. So I maybe want to compare a dry area to a wet area, or a sunny area to a shaded area, to a different area. And we could say here with a different abiotic factor. Great question there, Daniel, about the control variables. It's really, really hard to control things out in the field. It's really hard to control things out in the wild. So what I would want to do instead is I would want to make sure I do this at the same time of day, preferably, the same time of year for sure, because if I go and do this in the winter, there aren't going to be any daisies. So those are the sort of things that we would control when we do this. Okay. So let's just go through that maths and have a little practice of it. A student used a 0.5 by 0.5 meter quadrat and calculated a mean of 12.3 flowers per quadrat. Calculate an estimate for the total population. Well, initially I need to determine the mean per meter squared. So the mean per meter squared, and I'm going to do my mean number 12.3 divided by the area of the quadrat, which is 0.5 squared. And our answer is, grabbing my calculator, 12.3 divided by 0.5 squared. And we get a mean per meter squared of 49.2. Then our total population, we are now going to need to multiply the mean per meter squared by the total area. And I can see I've got a problem here because I've got this paved area in the middle of my triangle. So our total area, to work this out, I'm going to first do the area of my triangle. So half base times height, and the height is 10 meters. The base is going to be 6 plus 4, so 16 meters. So 0.5 times 10 times 16. And then I'm going to subtract from that the area, the paved area. So that's 3 times 6. So our total area comes out as, working it out on my calculator, and then 62 meters squared. So then our mean per meter squared is 49.2. Our total area is 62 meters squared. Multiply them together, and we get a total population of 3,050 to the nearest whole number, because you can't really have half a daisy, can you? All right, let's have a little look. So that's our maths done. Why do we need to place that quadrat randomly? So placing that quadrat randomly is super, super important in order to avoid bias. To avoid that bias. Yeah, fantastic there, Daniel. Super active on the chat. I love that. Why is it important to repeat placing the quadrat then? So the repetition here is to improve reliability. So we're going to improve reliability. And when we're improving that reliability, what we want to be thinking about is how does this affect the random error? When we're investigating an ecosystem, there's going to be loads and loads and loads of random error. So we want to try and reduce the effect of that random error. So it reduces the effect of random error. Any experiment where there's going to be lots of random error, there's going to be lots of uncertainty, we want to increase the number of repeats. So the students predict that people walking off the paved area reduces the number of flowers. Suggest a method the students could use to test this. What's the word that I'm looking for there if we're investigating how one area affects the distribution of those daisies? Well, what I need to measure how the distribution changes away from that area. So I'm going to place a line going away from that paved area. This is our transect. Great question on the chat there, Daniel. The point about repeating the quadrat, you just need to say improving the reliability. Okay, that's all you'd need for the mark. So what we're going to do is we're going to place a transect. So place a transect from the paved area outwards. And that transect is just the line through the ecosystem. And then once we've placed the transect, I can then place my quadrat along that transect. Then I'm going to place the quadrat along the transect. And by placing it along the transect, then at each point, I can then count the number of daisies. So count the number of daisies. But I also need to think about how I can measure the independent variable. Now, the independent variable is the abiotic factor. In this instance, it's the people walking. And the distance is our inference of that independent variable. We could be investigating light intensity, in which case I'd want to take a reading for the light intensity, or perhaps we're investigating the amount of water in the soil, so I'd want to take a measurement of that as well. So I'm going to count the number of daisies in the quadrat, and I want to record the distance. And as we're going to do this, we're going to repeat this at regular intervals along the transect. So repeat at regular intervals. So this could be every meter perhaps, or every 2 meters along the transect. Then as we continue to place it along the transect, we need to then repeat that transect as well. So repeat the transect in different position. And then we can plot our results and we can get an indication of the distribution of these daisies. So what might our results then look like? Well, a student measured the number of flowers along the transect between 2 woody areas now. At which distance was the greatest number of flowers recorded? So our greatest number of flowers, well, if we're looking at our graph here, we can see that between 12 and 14, we have the largest number there. We can see up to 8 individuals. So 12 to 14 meters. Now, I can't specifically say 13 meters because 13 wasn't measured. It was only at 12 and then again at 14. Then suggest an explanation for the results here. Well, between 12 and 14 meters, well, there's going to be the highest light intensity. There's the least amount of shade, so the greatest light intensity. And with having the greatest light intensity, this means that there's going to be the greatest rate of photosynthesis. And if we've got the greatest rate of photosynthesis, this means there's going to be the largest amount of growth of flowers. So the most amount of growth. Could you talk about less water absorbed from the ground, so more water for the grass? I think you need to talk about water absorbed by the trees there, Daniel. So you could say less competition for resources, for mineral ions, for water, and therefore more nutrients available for growth, or more mineral ions available for growth. And then finally, if we could look at 16 meters, we can see that there are 0 flowers recorded at 16 meters. Why might that be the case? Well, this is a suggestion. We need to think about what might a kind of suitable answer be, what could a sensible answer be, and we could maybe say something like, there's a footpath, so increased trampling. But also, this is just one repeat, so this could be just due to random error, due to chance and random error. And there we have it, our last required practical for paper 2 explained super fast in only 20 minutes. There we go. How do we feel about paper 2? I hope you are feeling confident. Don't forget to join the cram courses the night before your exam, Sunday evening, not this Sunday, next Sunday. And we're going to make sure we can go through absolutely everything for you. Yes, I love that, Daniel. Make sure you've signed up for the cram course. I hope you have already. Anyone else, make sure you sign up for the cram course as well. It's been a pleasure, team. Short and sweet. I'll see you next time.